All right, hopefully you did well on your quiz just now. Students in here did a great job with that, so hopefully you did also. We're going to finish looking at the homework now, page 195, numbers 2 through 10 to even. We were looking yesterday at analyzing where two equations would intersect each other. So how do we find points of intersection for two or more graphs? Class?
Addition or substitution?
Yeah.
Addition method or substitution method as we solve a system of equations. There we go. If you want points of intersection, use a system of equations. And again, could we use the addition method? Sometimes. Could we use the substitution method? Always, though sometimes addition or elimination may be easier. Number 2 on the homework, for instance, I feel like this first linear equation and the second linear equation would be easiest solved using the addition method. If I just did what, Quentin?
Change the signs in both.
Change the signs across the bottom, that's where the smaller numbers are. That'll allow these to cancel, and then I end up with?
3x equals 6.
So x just equals? But I'm not done, remember, because I'm finding a point of intersection for these two lines. A point has an abscissa and an ordinate. So to go back and get the ordinate now, Jamie.
Plug in the 1 for x in the top equation.
Yeah, we go to the one that we haven't messed with. We messed with that bottom one, so let's go to the top equation. It's not that much harder anyway. Make sure we do plug the 1 in for the x, not for the y by accident. That, of course, gives us
5.
Which I move over as a
Negative.
to get.
Negative 12.
So if negative 3y equals negative 12, then what does y equal?
4.
A positive 4. And we do get the point 1, 4. Both good to go there? All right, number 4, we have an x squared minus y squared equals 16. Do we remember what this shape is?
The ellipse.
We got the minus.
Not ellipse.
That's the hyperbola.
That's the hyperbola. Again, you don't have to have that memorized yet, so don't, get too frustrated if you don't have it. And then y equals x negative 8. Of course, we should recognize that as a straight line, right? Linear equation. And here, can I use the addition method? No. Because I don't have squares here, but I have squares there. What I'm going to have to use is the substitution method. And on the surface, it's already set up for me to substitute for the y. Here's my only issue. This little negative right here, my chalk slipped there. That negative right there. That could mess me up if I'm not careful. You may see fit to move the 8 over and say y plus 8 equals x and substitute for the x instead. That's a strategy tip if you're not positive that you can be careful with that negative. And you see what I did there? Okay. Anyway, that said, what did we do?
The y.
You plugged in for the y? Okay. It was already set up for you, so in one sense you say, well, that's just more direct and easy. Just be careful with the negative. So I'm going to keep the x squared. I'm going to keep the negative, and I'm going to put this value all in parentheses as I square, so I remember to apply the negative here in just a moment. All right, when I square the x negative 8, what do I get?
X squared minus 16x plus 64.
And then we're going to apply the negative to all of that to get
Negative x squared positive 16x negative 64.
Did we remember to apply the negative?
Not quite.
All right, and that was my concern, right? Negatives just, they mess things up. So again, a strategy tip is find the easiest spot to substitute or just be really careful. All right, at this point, Quentin.
Cancel the x squared. Move the 64 over as positive.
So you get 16x equals
8.
And so x equals?
5.
Now notice only one x value. Now that doesn't mean that we don't have multiple y values, but only one x value, interestingly. We'll plug the 5 in for the x. Now here's the key. When you go to plug this in, you're going to plug it into whichever equation has the lowest power. So we're not going to plug it into this quadratic. That's messy anyway. That's not lazy. Mathematicians are lazy. We go to the lowest power, which is this one. And we plug the 5 in here, and we get y is equal to negative 3. So while it is possible that a hyperbola and a straight line could intersect twice, it's also possible that it intersects only once. And that as the hyperbola continues to move away from the line, we get only 1 point. That's what happens here. Just the 1 point of intersection. Questions on this? Guessing we did not get the 5, negative 3.
Mhm.
All right, questions? Let's take a look at number 6. We have a 4x squared plus y squared is equal to 4, and we have a 3x. Positive 4y is equal to 12. Top equation, what shape?
The ellipse.
An ellipse, right? We have the plus between them. It's not even a circle. Remember, the circle would be if the numbers match, because then the ellipse is perfectly round. Here it's a distorted ellipse. And then here, of course, we have a...
Straight line.
So I'm expecting 2 points. Could get,
1.
also could get
9.
no points, right? But I'm expecting probably 2. And once again, we're going to have to solve using
The same equations. Oh, well, substitute.
substitution. Now here, it's going to be gnarly. There's not an easy letter to get by itself. But which is going to be the easier substitution once we get a letter by itself? The x or the y? Definitely the y. So I'm going to get the y by itself, even though it's not going to be pretty. Let's do it anyway. What do we wind up with when we get the y by itself, Quentin? 12 minus 3x all over 4. And we're going to take all of that and plug it in for the y. So I get a 4x squared plus ugly is equal to 4. Now when I square the ugly, let's start with the easy part. Let's square the bottom. And then when we square the top, we got to square the first, square the last, multiply and double.
4,
Minus 26.
No, 36
72
times
later.
2. Yeah. And then 9 squared.
Now the good news is, as ugly as that is, I can actually get rid of ugly pretty quickly.
Multiply by 16 everywhere.
Multiply everything by 16. So 16 times 4x squared.
64x squared.
Of course, the 16s here cancel. I've got the 144, the negative 72x, the positive 9x squared, and then 16 times 4, 64. It's still pretty ugly. Let's combine some like terms here.
73.
Ooh, careful. 73x squared minus the 72x. And let's bring the 64 over as a negative 64, so we can set it equal to 0. Now, normally my next step would be to factor. This is actually what the video cut out yesterday. Normally my next step would be to factor. No. All right, so that means my other options are complete the square, but with a 73 in the front, that has to be factored out first. So my other option is to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Yeah. All right, so let's start. Negative b. What do I plug in?
72.
A positive 72. Negative 72 gives positive 72. Plus or minus the square root of, calculator's ready, b squared.
5,184.
How much?
5,184.
That sounds good. 5184 minus 4 times a times c.
I have negative 18,976, but that could be wrong.
Let's see what you got, Quinn. You like 18,176?
I got 23,360.
Hold on, let me get my calculator. 4 times 73 times 80. I got 23,360. You like that number better?
Yeah. I don't think that's going to be the final answer.
Oh,
but,
all over 2a. What's 2a?
146.
All right, now, thoughts on that? It's going to be a negative big time, right? Can you take the square root of a negative? No. which means this is going to be imaginary. And remember from yesterday, if it comes out imaginary or complex, no real points of intersection. Well, that got us off the hook. That makes me not as mad. Okay.
Why do I have to do this for homework?
I stopped right there at the 73 squared.
I thought I could just square. I know we're not supposed to do this, but I squares like the one of the equations, and I still got no real points of intersection because I ended up with a square root of a negative. So
yeah, don't square. If you're gonna square, you have to square both sides.
Yeah.
You can't square everything, and so that makes it rather painful. All right, questions on this? All right. Well, you know, I guess let's follow Jamie's line of thought for a second here. Let's follow Jamie's line of thought. If you left this all together and squared that side, you'd end up with an xy term, right? Square the first, square less, multiply and double. But what if we ditched that 4y and then we squared both sides? We wouldn't get an xy, would we? We would get a 9x squared is equal to 144 minus 96y plus 16y squared. And then, if I ditched the y squared as a negative y squared, and then if I multiplied this by 9 and this by 4, I can get a 36x squared equals 36 minus 9y squared. And here I can get a 36x squared equals, oh goodness, I don't like Jamie's way.
I actually forgot about
576 minus 384y plus 64y squared. And if I change the signs across the top and I add, then that'll allow this to drop out. I'll get 0 is equal to 540 minus 384y plus 73y squared. And now I can solve that quadratic.
I forgot about the multiply.
It's about as bad as that one, maybe slightly worse. But I mean, you could do that, I guess. You just don't want the xy term.
Yeah, I forgot about that.
Substitution, not addition. All right, because it still gets you to a gnarly place. All right, let's move on to number 8. So that line on number 6 and that ellipse never intersect. The line misses the ellipse completely. Number 8. We've got a cubic. Now remember, a cubic is the one that does like that thing, okay? And then we've got a straight line. How many places could a cubic and a line meet?
1, 2, 3.
Yeah, I mean, I guess depending on, like, if it came through like that, you could get 3. If it came like that, you could get 2. If it went like that, you would get 1. I think even if it was like this, it would eventually hit either this, or if it angled differently, it would hit that. So I think you're at least going to get 1. I don't know that you could get 0. I think we're destined to get at least 1, maybe 2, maybe 3. So let's look at our cubic here. Y equals x cubed negative x, and then y equals 3x. Thoughts? Yeah, I mean, it's already set up to solve by substitution. Let's just replace this y with a 3x and say 3x equals x cubed minus x, okay?
Move the x over as positive, so...
I've got a bad feeling about this, but let's write it out. Remember, higher power equations. Set them equal to 0 and factor. So let's, instead of doing that, let's set it equal to 0. And let's get x cubed, bring the 3x over as a negative. Yeah, remember, just like we did with trig equations, right? If they had higher powers, set them equal to 0 factor. Quadratic, set them equal to 0 factor. Higher power, set it equal to 0 factor. So let's factor.
Quantity of x squared minus 4.
We could actually factor more if we wanted to.
X minus 2 squared.
X minus 2 times x.
Difference of squares, sum and difference, x plus 2, x minus 2. Maybe it'd be better not to factor. Maybe we say that x equals 0. Maybe we say x squared minus 4 equals 0 so that now we can... Questions? All right, so we wind up, notice, with 3 x values. An x value of 0, an x value of 2, and an x value of negative 2. Now, where do I plug these values in? Which equation? The lowest power equation. If I plug in a 0, I get... If I plug in a 2, I get... If I plug in a negative 2, I get... And sure enough, we have 3 points of intersection that we should have gotten here. Doesn't sound like that one went so hot. Questions?
I got one.
All right. Questions? 7 equals 0 factor.
Yeah.
Well, let's take a look at the last one you had from homework. Numero 10. Top equation is...
4x squared plus 4x.
Yeah, but what is that?
Ellipse.
It's an ellipse. And the lower equation?
Straight line.
Now, the last time we had one of these, it missed. So maybe this time it will actually intersect. Let's find out. X plus y equals 6. Now, Jamie, are we going to square both sides on the bottom? No, we're not going to. What are we going to do instead, Jamie?
Substitute.
We're going to solve by substitution, aren't we? And that's a very good idea. So, which letter do we want to substitute for?
The y.
The y, for sure. That's easier. Otherwise, we have to distribute after we square. I don't want to do that. So let's get the y by itself, and let's rewrite the lower equation.
Y equals 6 minus x.
And let's put that right there to get what, Jamie?
It'll be 4x squared plus recliner 6 minus x squared equals 20.
Okay, well, I was kind of expecting you to square it, so let me come back to you.
Okay. Well, it'll be 36 negative 12x plus x squared.
And then, of course, we have the 4x squared there. Okay, now, Quentin, let's go to you.
Combine my terms and set equals 0, so 5x squared minus 12x or plus 16 equals 0. And factor 50.
At least the numbers aren't scary. Worth a try. I definitely don't want to complete the square, right? Oh, with a 5 right there.
Not complete the square.
With a 5 right there? You'd have to factor the 5 out.
Yeah,
So remember, the key to completing the square, you have
I
to...
also completed this.
But you can't pull a 5 out, can you?
No.
So we're not completing the square. It's either formula or factor. Look, we try factoring. Right? 5x, 1x, signs. There's a few ways to split up a 16.
1, 16.
Yeah, no, I don't like that one.
4 and 4.
That ain't gonna work.
2 and 8.
2 and 8, 8 and 2. I don't think it's gonna factor. I think we're gonna have to use the quadratic formula. Say it with me. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Write it on your paper.
Okay.
The old quadratic formula making his comeback. It's like that pesky girl you dated in junior high and she won't go away. That's for Quentin. For Jamie, it's that pesky guy who just won't leave you alone and keeps calling. He's the reason your dad has the shotgun loaded. I think it's always good to keep a shotgun loaded. But anyway. All right, so now that we've written it down, let's say this together, class. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, strategy tip. Last time we got off the hook because that came out negative. Do you remember what we call that thing? It's called the discriminant. Do you remember that term from Algebra 2? It's been a long time. The discriminant. It's the term, it's the part of the equation that tells us whether or not we have real or imaginary answers. let's just solve that. Forget the rest of it for a minute. What's b squared?
144.
144 minus 4 times 5 times 16. What's 4 times 5 times 16?
320.
And that's going to give us a, so we're off the hook. I just write
No real points of intersection.
no real points of intersection. And we don't have to do anything else. Why plug in for the rest of it? Now, if that came out positive, bless our hearts, we're stuck solving the rest of it, right? But start with the discriminant. Start with the radicand of the quadratic formula and see if maybe you can get off the hook. And once again, the line and the ellipse miss each other. Singularly unsatisfying, right? But easy. All right, questions on number 10. All right, let's go back now and let's take a look at number 11. We changed one number. Instead of a 6, it's a 5. Let's see if that one number change allows us to get points of intersection or if we're right back in the same boat. Figuratively speaking, of course, we're not really in a boat. We're in a classroom. So once again, let's start by rearranging the bottom equation.
Y equals 5 minus x.
Once again, let's plug the 5 minus x in for the y to get 4x squared plus
25
Minus
10x plus
all equal to 20. Once again, let's combine like terms.
5x squared.
Minus the 10x
Plus 5.
equal to the 0. Now, if we wanted to complete the square, we would have to factor out a 5. And this time you can. We can, in fact, knock a 5 out of everything.
x squared minus 2 plus 1.
Wait a second. I don't need to complete the square.
Add factors, yeah.
I'm going to factor the other way.
X minus 1x.
And that works, doesn't it? So I get what? 2 abscissas.
Positive 1. Positive 1.
In other words, just positive 1. So my straight line and my ellipse share an abscissa. They intersect at the abscissa of 1. What's the ordinate? 4. So while you'd think, okay, line and ellipse, if they intersect, they're going to intersect twice. Well, if it's tangent, those 2 points are coincident. Picture this. Ellipse, straight line, 2 points. 2 points. 2 points, they're getting closer. 2 points, they're really close. If I could zoom in, 2 points, they're even closer. If you get those 2 points to coincide, there's just a single point of tangency now. So that's why it looks like you're going to get 2 points because it's quadratic, but it actually just comes out to 1 point of intersection. All right, questions on number 11. To number 12, it's your seats. Once again, a cubic comes in. Jamie, talk me through it.
We're going to substitute the y for the 4x.
Okay.
Right? And so it'll be 4x equals x cubed. Then we'll move the 4x over as a negative, so that is set equals 0. So 0 equals x cubed minus 4x.
Good. Set them equal to 0.
Then we factor out an x. The x times x squared minus 4.
This looks familiar.
Which we can turn into x times x minus 2, x plus 2.
So it gives us what x values?
0 to negative 2.
Again, looks very familiar. We're going to go to which equation to plug these in?
The bottom one?
The lower equation. And so when we plug them in, plug in a 0,
0,
2,
8,
negative 2.
negative 8.
And there's my 3 points of intersection. All right, questions on that? Homework for this evening is to do page 195. Page 195, do numbers 3, 7, and 9. 3, 7, and 9. Also, I want you to read over pages 196 to 200. We're going to look at some really interesting graphs. We've been doing, ordinary shapes. There's going to be some really cool shapes in the next section. I want you to read over 196 to 200 in preparation for that. All right, have a wonderful rest of your day.